Hi everyone, in this video we are going to discuss about the laws of exponent. Now first we are going to talk about the exponent notation. When a number is added repeatedly with itself, then we represent it like this. Say for example, we are adding a number a repeatedly with itself, then we represent this as, or we denote this as 5 times a, because we are adding 5 a's together, right? So this becomes 5 times a, 5 of the a's, right? Now instead of addition, if we do multiplication, then how is it going to look like? So this is a times a times a times a times a. We are multiplying a repeatedly with itself 5 times. So the total 5 a's there in multiplication form. Now how are you going to denote this? Well, for this one comes the exponent notation. And this is going to be denoted as a with a number 5 right there on the top right corner. And that 5 is actually called the exponent or the power. So because we are multiplying a 5 times repeatedly, we denote this product as a with a 5 on the top right corner. Similarly, if a is repeatedly multiplied with itself m times, then it's going to look like this. So here I have a times a times a times a all the way up to m times, right? So this multiplication is happening m times. So there are m number of a's here in this product. So this will be denoted as a with an m on the top right corner. Now what is it called? Well, it has a specific name. This little m right here on the top right corner of a, this is called the exponent or the power. So let me make a note. The regular name is exponent, but of course it could be called as a power or even degree. Sometimes somebody might say, hey, what's the degree of this expression, right? So that little m is called the exponent or the power or the degree, right? And then does the a also have a name? Yes, it does. So a also has another name. So let me make a note here that a is called the base. So the base has been repeatedly multiplied m times. So this symbol means that the number a has been multiplied repeatedly m times. And which symbol I am talking about? Well, I am talking about this symbol right here. A with a small little m on the top right corner. This symbol right here, this symbol means that the number a has been repeatedly multiplied m times with itself. So how is it read actually? If you see this symbol a with a small m on the top right corner, how should we read it? Well, this is actually read as a raised to the power m. And also this word raised right here, this can also be silent sometimes. Sometimes it can be read as a to the power m. Also it can be read as a to the mth power. And also it can be read as a to the mth, where the word power is silent. Sometimes this word can also be silent and it can be read as a to the mth. So if somebody says a to the fourth, then you know that we are talking about the power fourth for a. That means a has been repeatedly multiplied 4 times. So if somebody says a to the mth, you know that a has been multiplied repeatedly m times. So there are different ways people read it, but generally you will see the two styles here, a to the mth or a to the power m. I prefer the first one. That's the one I have learned during my school. So I'll be reading it as a to the power m. Now let's take a few examples. So suppose we are repeatedly multiplying a number, let's say 2 times x. This is a number, right? So we multiply that with itself again. So suppose we multiply again one more time, let's say, and maybe one more time. Then how should we denote it? Well, this will become 2 times x to the power 4 because we have multiplied it 4 times repeatedly, right? So this will be 2x to the power 4. Next, we are going to talk about the properties of exponent, which is very important and it needs to be very clear to everybody. So let's get started with the properties of exponent. The first property that we are going to learn here is multiplication of a to the power m with a to the power n, right? So let me write it down. So the first property says that if a to the power m is multiplied by a to the power n, then the product would be a to the power m plus n. The power itself will become the sum of the two little powers. So how does it work? Let's take an example first. So here we are going to take an example. Say suppose we have 2 squared times 2 cubed. For example, right? So 2 squared is what? 2 squared is actually 2 times 2. And then what is 2 cubed? Well, 2 cubed is again 2 times 2 times 2. So the first portion was 2 squared. So this is 2 squared. And then the next portion is 2 cubed. So this is 2 cubed. Now how many 2's do we have? Well, here we see there are 5 2's being multiplied together. So now this becomes 2 to the power 5. So this becomes 2 to the power 5. Now you see, where did this 5 come from? Well, actually it's the 2 of the 2's from the first factor and then 3 of the 2's from the second factor. So that 2 plus 3, that becomes 5 because we have so many factors now, right? So we can write it as 2 to the power 2 plus 3. So similarly, if we say, okay, we have a to the power m times a to the power n, and this is going to be what? Well, this will be a times a all the way up to m number of factors. So this is m number of times. And then also we have the a to the power n. So that would be again a times all the way up to n times. So that would be n number of a's there. So if you look at this full picture here, you see that in the first portion we have m number of a's and in the second portion we have n number of a's, right? So total how many a's we have? Well, then total we have m plus n number of a's. So can we write it like this? So we can say this must be equal to a times a times a times a all the way up to times a, but we are going to now call it as how many times? We are going to call it m plus n times because we are combining so many a's together. We are multiplying so many a's together, right? So then finally this can be written as a to the power m plus n because we have so many a's being multiplied together. So this is where the property came from, right? So a to the power m times a to the power n is actually a to the power m plus n. So let's take an example. Say suppose we have a to the power 6 times a to the power 7, and this will become a to the power 6 plus 7, which is equal to a to the power 13. Let's take another example. Suppose we have x to the power 5 times x to the power 10. That will become what? That will become x to the power 5 plus 10. So the power becomes 5 plus 10. So that will be x to the power 15. And similarly, if we take another example, let's say suppose we have a to the power 10 times a to the power 20. That will become a to the power 10 plus 20, which will be equal to a to the power 30, right? So I want to mention two quick things here. I should have mentioned earlier, but let's quickly discuss that. So suppose if somebody says, hey, I have just a number 2 times a. So what is the power of a? Well, 2 we understand that's a numeric coefficient, but what is the power of a in this expression, right? Well, the power of a is actually 1. So in this expression, we can say that power or degree or exponent, whatever you may call it, power of a in this expression is actually 1. When there is no power written, you can safely assume that we have a 1 there. No power explicitly written means the assumed power is 1. So we have to always assume that the power of a here would be 1. And this is very important to remember, that no power written means the power is 1. Now, if the power is 2, for example, so we have seen that if you have a with a power m, this is read as a to the power m. Right? Now, if we have a number like this, say suppose we have a number a with a power 2. So, should we read it as a to the power 2? No, actually it is read as a squared. So, you want to read it as a squared. And similarly, if we have a number a with a power 3, should we read it as a to the power 3? Well, that will not be totally incorrect, but it is generally read as a cubed. So power 3 is read as cubed, power 2 is read as squared, and anything above that, if your power is more than 2 or 3, then we can read it as a to the power whatever, right? So suppose we have a with a power 4, we should read it as a to the power 4, or you can also read it as a to the 4th power. A to the 4th, or maybe sometimes people can read it as a to the 4th power. They all mean the same thing. As long as you understand what it means that a is being repeatedly multiplied total 4 times with itself. So total 4 factors of a, that product would be a to the power 4. Alright, now let's talk about the second property of exponent. So the second property says that if you have a to the power m divided by a to the power n, then this quotient or the result of this division would be a to the power m minus n. The power will be reduced by n times, right? So let's take an example. So suppose we have 2 cubed divided by 2 squared. I'm just taking a simple example. Now, so 2 cubed is what? 2 cubed would be 2 times 2 times 2. and then 2 squared would be 2 times 2 in the denominator. Now as you can see, this is in a fraction form, and then we can divide both the numerator and the denominator by the same number, and that way these 2 will cancel one of the 2's down below, and then another 2 will cancel the other 2 in the denominator. So now we are going to be left with just one 2 there. So this is just a 2 there. Now what does it mean? Well, there is no power. No power means just 1. The power is 1. Now can we write it like this? So this 2 to the power 1, it can be, this 1 can be 3 minus 2, and that's exactly what is happening here, because see, we originally had power 3 in the numerator, and then we had power 2 in the denominator. Now how many ever powers we had in the denominator, it will try to cancel as many factors in the numerator. So the ultimate power after the division will be reduced by whatever number of factors we had in the denominator. So that is the reduction. We started with 3 in the numerator, but in the denominator we had 2 powers or 2 factors. So then final result will have 3 minus 2 powers of this base. In this case the base number is 2, right? So then if we have a to the power m divided by a to the power n, and we can write it as a times that would be m times, so we have m number of a's in the numerator, and then in the denominator how many do we have? Well, we are going to have a times we are going to have n number of factors here. So we have in the numerator, I'm just writing it here, we have m factors, and here we have n factors. Now if you think about it, if m is greater than n, then what will happen? All of the factors, they will get cancelled between the numerator and the denominator, right? So ultimately how many we are going to be left with? Well, from here we are going to be left with only as many as m minus n. We simply need to subtract n from m to get the final number of factors of a, right? So this will be the quotient of this division, and the end result will be a to the power m minus n. So let's take an example. Suppose we have 4 times x to the power 5 divided by 2 times x to the power 4. Now what would be the result here? Well, 4 divided by 2, that will give us 2, and then for the x it will have a power of 5 minus 4, and that would be 2 times x, because 5 minus 4 is 1, and for 1 power we really don't explicitly show the power, we just simply write it as x. That means it's x to the power 1. So the end result is here 2 times x. Now from this property there are a couple of interesting results what we are going to discuss now. So let's quickly discuss about this one property here. So let's discuss about the first result here, and the first result is like this. If somebody says a to the power 0, what would be the value of that? Well, a to the power 0 actually means 1. Now why is it like that? That's what we're going to learn here. So suppose a to the power 0, can it be written like, suppose I'm writing on the side here, if we have a to the power 0, can we write it as, say, a to the power maybe m minus m? We can write it like this, and then you can see that, okay, can this be written as a to the power m divided by a to the power m again, because that's what we saw in the previous property, right? In the property number 2 we saw that a to the power m divided by a to the power n gives us a to the power m minus n. Now in this particular example we have the same power m minus m, right? So then we can express it like this. Now from here you see our numerator and the denominator, they both are the same number. So equal number dividing each other, that would become 1. So ultimately this will become 1. So that is how we got a to the power 0 as 1. And it is very important, you want to make a note of this. And if somebody says, hey, what is a to the power 1? Well, a to the power 1 is actually a, that we have already discussed. I just wanted to quickly mention about it, that if the power is 1, that means it's being multiplied just 1 times, that means it's just a. So a to the power 1 is a. Or if somebody says, hey, what is b to the power 1? Well, that is equal to b. If somebody says what is x to the power 1, well, that is equal to x. Now let's talk about the next interesting result from this property number 2, and that is going to look like this. 1 divided by a to the power m can be written as a to the power negative m. Now where did it come from? Well, let's look at this. So suppose we have 1 divided by a to the power m. Can this be written as a to the power 0 divided by a to the power m? And then from property number 2, can we write it as a to the power 0 minus m? And that gives us a to the power negative m. So let's make a note of that also. And the third result that we're going to discuss here is kind of like this. So suppose we have a to the power m. Can it be written as 1 divided by a to the power negative m? Let's try to prove it. So suppose if we have a to the power m, can we write it as a to the power 0 plus m? Can this be written as a to the power 0 minus negative m? Then obviously it can be written as a to the power 0 divided by a to the power negative m, and a to the power 0 is 1, then divided by a to the power negative m. So all we have to remember is that if you have a form like this, if somebody says 1 divided by a to the power negative m, then you know that it is actually a to the power positive m. Or similarly, if we say 1 divided by a to the power positive m, that is actually a to the power negative m. So it's the reciprocal of each other. So let's make a note of this property also. Now we are going to discuss about the third property of exponent, and that is kind of like this. So in the third property, we say that if we have a times b whole to the power m, then we can write it as a to the power m times b to the power m. And also vice versa. If we have a to the power m times b to the power m, that can also be written as a times b whole to the power m. Now how can we prove it? To prove this property, we have a times b whole to the power m. So that means we have a times b multiplied by again a times b, and this multiplication goes on up to m times. So this a times b, this little number would be multiplied by itself m times. So that would be m times. So now if you think about it, how many a's do we have? Well, we have 1, 2, 3, 4, etc. up to m times. So there would be m number of a's, and similarly there will be m number of b's also, right? So we are going to write it as a times a times a times all the way up to m times, because we are going to have so many factors here. So this will be m times, and then we cannot forget the b, so we have the b also. So b times b times b times b, that is also m times. Let me highlight again. See, we have all these a's right here. I am underlining the a's. So you can imagine that there would be m number of a's. And similarly, if we underline the b's, I am underlining with a yellow line here. So there will be m number of b's also in this product, right? So there will be m number of a's and also m number of b's multiplied together. So then it is going to look like this, and then from here we can easily say this can be written as a to the power m. This first portion, it becomes a to the power m because there are m number of a's there in this product, and then multiplied by, then if you look at the b, there also we have m number of b's. So we can say that it would also be b to the power m. So a times b whole to the power m is equal to a to the power m times b to the power m. Let's take an example. Say suppose we have 2 times x to the power 4. So this can be written as 2 to the power 4 times x to the power 4. So this will be 16 times x to the power 4. Now let's discuss about the fourth property. The fourth property is going to look like this. So the fourth property says that if we have a to the power m whole to the power n, then it can be written as a to the power m times n. The exponents will be multiplied, right? So how does this work? Let's take an example. Let's say we have 2 squared whole to the power 4. So what does this mean? Well, this means that 2 squared, this number has been multiplied 4 times, right? So let me write it like this. Now from here, if you expand each of these factors here, so again 2 squared is actually what? 2 squared would be 2 times 2, and then again another 2 squared would be 2 times 2. Similarly, the third one will be 2 times 2, and the last one will also be 2 times 2. And then if you open up all the parentheses, how many 2's we are getting? Well, we are getting 1, 2, 3, 4, 5, 6, 7, 8. We are getting 8 2's. So this will become 2 times 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 2. And that is going to look like 2 to the power 8. And can we write it like this? So this 2 to the power 8 can be written as 2 to the power 2 times 4. And that's exactly what this property says. That if you have a to the power m whole to the power n, then it can be written as a to the power m times n when you multiply both the exponents there. I hope it makes sense. So let's take an example. Say suppose we have 3 times x squared whole to the power 4. So this will be 3 to the power 4 times x squared to the power 4. So 3 to the power 4 will be 81, and times x squared to the power 4, that would be x to the power 8. So we can write it as 81 times x to the power 8. Now let's talk about the fifth property. The fifth property says that if we have a divided by b whole to the power m, that can be written as a to the power m divided by b to the power m. How can we prove it? Well, let's see. So if we have a divided by whole to the power m, can we write it like this? That means we have a divided by b. This is the base number which is being multiplied m times with itself. So we can say that a divided by b times a divided by b again times a divided by b, and this goes on how many times? Well, this goes on m times. And then if we remove the parenthesis, so this will become a divided by b again times a with a b in the denominator again times a in the numerator and then b in the denominator, and this goes on how many times? Well, this goes on m times again. So in the numerator we have m number of a's and in the denominator we have m number of b's. So then we can easily say that, well, this then must be equal to a to the power m and divided by b to the power m. So then ultimately we see that a divided by b whole to the power m is actually a to the power m divided by b to the power m. So let's take an example. Suppose we have a number like this, x squared divided by y cubed whole to the power 4. This can be written as whatever is in the numerator, which is x squared, its power 4, and then divided by whatever is in the denominator, which is y cubed, its power 4. And then from the previous property we can say, okay, this must be x to the power 2 times 4, and then in the denominator it will be y to the power 3 times 4. That is from a previous property number 3 or 4, right? Ultimately this becomes x to the power 8 whole divided by y to the power 12. Let's take another example. Say suppose we have 2 by 3 whole to the power 4. So we can write it as 2 to the power 4 divided by 3 to the power 4 according to this property. So this will become 16 divided by 81. Maybe we can try one more example. Let's say we have negative of 1 divided by 5 whole square, for example. Now how are you going to handle it? Well, we are going to do it like this. Let's say suppose this is negative 1 times 1/5 whole squared, and then we are going to apply the square to each of these factors here. So this one factor will get a squared and this other factor will also get a squared. So we can write it as negative 1 squared times 1/5 squared, and negative 1 squared is actually positive 1 times 1/5 squared would be 1 squared divided by 5 squared. So this will be 1 times anything, right? So I'm not going to write the 1 again. So then in the numerator we are going to get 1, and then in the denominator we are going to get 25. So this is actually 1 divided by 25 or 1 over 25. So 1/25th, that is the answer for negative 1/5 whole square. Also let me quickly point out one little thing here, which is suppose if we have 1 divided by a to the power m, this can also be written as 1 to the power m divided by a to the power m. So this is a very interesting property of 1 that we are using here, that no matter how many times you multiply it with itself, ultimately it always gives you 1, right? So this 1 that we had, I simply wrote it as 1 to the power m, because you can raise 1 to any power, its value will still be 1. So from here we can say, okay, then this must be 1 divided by a whole to the power m. So this is a nice little property that you can remember. Well, it's actually not a property, it's a result from one of the previous properties. So let me quickly make a final note here. So this is 1 divided by a to the power m can also be written as 1 divided by a whole to the power m, right? I hope everything made sense. Thank you for watching. See you in the next video.